So it looks like I got another test from my man here. I guess I'll have to do a couple of tests. Go through a couple of tests before I get any credit from him. And that's going to be our Latitude. Latitude asked me to show me Grady's video. The engineer, Grady's a student. And Grady showed how he can put down his carload on top of the layers of... Let me just cut to the chase here. So Gator Grid is a product that you can buy. This is not Gator Grid, but Grady did something like a cloth, right? So here's our angle of repose. I put a load on this, and it's just sand. Let me make sure you can see it. It's just sand. Not sure if we can see this properly. Give me a second here. All right, the sun's killing me here. So hand. Oop, better zoom out then. All right, I got a short window. Looks like thunder's coming. So as I press down, you see the soil kick out? Let's put that back now. Now let's just put, same thing. Let's just throw a bag there. Now all that's going to happen is the bag is now created two shear planes. The bag is plastic. It's not going to allow permeability. In fact, it will allow water to build up on one side of this and create this so you get a landslide. You can slide off this one section. Let's see if that was showed up there, the landslide. All right, but let's put it back anyway. Let's make it kind of level. Let's just use the bag and load the bag. All right, so I'll put pressure on the bag. The bag is pretty much going to transfer the load the same way. The bag is being so thin. The bag is going to do the same thing. Nothing's going to change there. Why? The bag is elastic. It's going to stretch. And it created a bond breaker between the layers below. So the angle of repose was limited to here, and then it just transferred the load just like that below. That's all that happened. There's nothing magical about using a straight bag, something without a grid, without a way to allow interlocking below. Got metal here. We put metal there. We put metal here. Layer it. Another. Make sure you guys can see it. Another piece of layer of metal. You've got 1, 2, 3 surfaces of friction that it's got to make its way through. Of course, the load will depress it. But let's see if I can do this for you. Let's do this. And I need something a little more fair, a little more equal in pressure. So we're going to use these guys. And if you saw, the sand below started crumbling out. Let's do a little zoom in on that. We should be able to get it again until it's totally compacted, and then it won't. You'll have no effect at that point. So let's go again. Look at the sand down here as I load it with another brick. Some fell off the top. Well, that's the angle of repose changing for the top layer. It's now, so let's do this. See what happened? It now shifted all these stones, these aggregate, now become interlocked on themselves. They're acting like a grid. They're interlocking, they're becoming more compressed. They're changing their composition to help. And now water, of course, would undermine that. Let's pull it off. And let's talk about this this metal had no ability, with that load put on it, to stretch. No ability to stretch. And that's why it's better than 3 layers of plastic. As you see there, no ability to stretch. All right, I mean it stretches rather. So now let's use, you can grab any product to experiment with yourself. We're now going to grab, and this is an expensive product actually. It's a mesh for like a drive-it system for coating. It's going to stop your elongation. Let's just cut some layer out of this real quick. So bear with me. I'm just going to run down the one edge of it. Okay, so all I did there was create some layers. So there's the sand. If I was just to try to pull this across the sand, all this would create friction, and you can imagine one pile running into the other, all working against each other. But as I pull on this on opposite sides, it will elongate so much, and that's it. Let's go ahead and put that in there now, and let's cut off another section. So this will be stronger in this direction than in that direction. There will be more elongation in the longer direction than this way. So how I load it will matter too. You can create a profile with this if you're kind of cute about it. Nobody does that, but let's just lay it flat. Let's lay it flat and let's tamp it, if you will. So let me come up with a sort of a flat surface. Well, I got a profile there. Let me try to get a little more flat there. Okay, there's our flat surface. Now, let's go ahead and layer it again. Obviously I'm not doing this with the level and perfectionist like I could. We're just doing it like this, sort of just winging it. Sort of winging it. We'll just go with 3 or 4 layers. Here's the third layer. So there's the third layer, and let's go ahead and you can see the edge of it here. The material's right there. Let's do that. Here's the edge of the material there. Let's put some sand up next to it. Not really compacting it, just put it up next to it. Oops. So now you can imagine if I put a load on top of this, see how it's not coming out? Because even though it looks like, and I'm really pressing on that, even though it looks like that the soil is, and I've got 3 or more there now, the soil, nothing's changed. It's putting this in tension. This fabric is now in tension. As the loads come down, it pushes out on the 45. It's pushing this equally as I load it, pushing the fabric that way in a cutaway, if you will, 45. So this is going through this fabric in this capacity. So yeah, you can find weakness in your materials on the other side of that 45. But for example, I should be able to fold this all the way up and get the same results, right about a 45. So somewhere about there as I load it. Now if it changes the angle of repose, I could add more fabric. But we're looking at the loads are coming down. They have no choice but they're going that direction. They're putting this in tension. This is not only working, so it's working in that capacity, and it's also working in the capacity of making the soil, the material more stable, because now the material has friction between one layer to the other layer, the 3 layers here. Let's go ahead and clean that out, the 3 layers. It's creating that this forces are coming down there are being resisted by this one, resisted by this one. It's stabilizing the soil. Now, that's the way the fabric is made. It gets you there. You can do this other ways, such as soil cement. I got videos coming up with soil cement. Soil cement's very interesting. Very interesting. This is just a video response from a man. Hopefully he'll get it. Now, Grady stated he uses a heavier screen in his video, as Latitude sent me to, and that's what was able to get his results. It's not the heaviest screen, because if I used a 6x6 mesh of rebar, you can see that it would not make a stable surface. It would be out here and here, and it's nothing is really doing. It's not stabilizing this material. This material is not stabilizing it. There's your angle of repose right there as a release. There we go. It's a little moist down there. It's pretty bad. All right, so now you see what's going on there. Now you see what's going on there. Now, if we wanted to know the limits of this and extrapolate from there with this fabric, you sure could. You'd have to make up your section and it would be dry, and then you could add moisture to it to see what would happen. Sorry about the shadow. Hold on. Now remember this. We just created 3 layers on top of soil still. So this shear plane is still here. It's now here though, instead of, anywhere. It's now there. I'm going to add 1, 2, 3. 3 more blocks to that. 3 more bricks. So now we're up to 6. And we're still stable. We're still stable. Now let me grab 3 more. So this is acting as one on all of this all together in one shot now. So it's giving the loads, transferring the loads down to the sand, and at the base of wherever this ends at, it then is now equal loading it. So that's now we're at another one. So that's 7, 8, 9, and we're only at, and because that fabric is in tension, with fabric will fail. So now we're at 9, 3, 6, 9. So the fabric, it will fail, or the shear plane will fail. In this case, I don't think the fabric's going to fail. I think the shear plane moving down, that we're going to see that it's going to fail at the soil point below this. As it's transferring this load, the soil's going to be overloaded. Let's grab some more. Hold on. So in other words, the soil and not where we put the fabric is going to tap out on us. Here we go. Now we're at a huge, significant amounts. Look at this guy. Let's back it up a bit. And let me see if I can get you a little... You know what? Let's come back over here. Hope I don't trash my camera. I'm trying to predict which way it would fall. And that's like not going to be, if it depends on the weaker side. So there's a good chance I'll trash my camera in this deal. Okay, again the soil will be the failure here, not between our layers. I don't think we're going to make enough to cause our layers to our friction to fail. Remember, the base is in tension, those fabrics. Now look at us, helping you visualize what took place here. Let's keep going. Bear with me. I can't adjust the camera on an angle for you, sorry. Bear with me. So we're at 3, I don't know where we're at. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16. Is that right? 3, 6, 9, 10, 11, 12, 13, 14, 16. 17. 18. 19. 20. And you guys saw it live. They were at 20 now. I'm done. I mean, it's just huge. So you can count them. I think that's 20. 5, 6, 7, 8, 9, 10, 11, 14, 15, 16, 17, 18, 19. What? 3, 6, 9, 12, 15, 16, 17, 18, 19. Oh no. I got to do the round number now that I did it, now that I said it. We've got to hit 20 now. Because I made a conclusive file, there's 20, right? So there, we got to hit 20. There's a slide I mentioned. It's failing. See the slide? Okay, so you saw the slide that took place, and it was below the fabric, and we saw that how it was loaded. But you're looking at our landslide. Our surface didn't fail between our layers, as we can see. The layers are awesome. Let me tilt that down for you. The layers in here are awesome. It was the soil below that no longer needed more reinforcement. So we would add more fabric down there to help it with its shear plane, with its forces that it couldn't hold up any longer. So that was awesome. Let's go ahead and pull that aside. And obviously the layers are what the layers are. Now, same soil. 1, 2. Now, this is, so 45 it. Same thing I did there. And I cut away a little bit, right? So same thing. Now, 4, 5. Ooh. Already we're getting sinking already. This is unfair to it because it's already sinking. It's changing. It's already sinking, so it's changing. It's compression, changing the soil dynamics. You watch it there. Let me make sure you guys can see it. Yeah, you watch it there, and you'll see that it's changing. We're at 6. It's already changed. Whatever you want to add gives me a new result. 7, 8, and I'm going to stack these a lot more cleaner to hopefully get to this. I'm trying to ultimately get to the same failure. Let's see how soon it would get there. Although it's compressing, and I also have the balance of the wall down here now helping. The soil around it is pushing back. So to fairness, I got to cut that away. There we go. So let me make sure you can see what I did. I don't want you to think I did any magic act. All right, so for fairness, I just cut it away similar to where it was without the balance. Come on, cat, don't come here now. But you see the soils are compressing and doing its thing. Oh, I chipped one of them in that damn experiment. All right, it's already fallen over to the right. I'm sort of counterbalancing it now. Here it goes. It's gone. So I'm going to hold it in the air. And let's count them up. So, 1, 2, whoa, baby. It's still holding. I'm using a lot of counter force on it. 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15. And it's failed at 14 because 15 couldn't make it. You see what's going on there in the soil? I'm just helping it. I'm going to put it back a little bit and try to break it down. Now let's have a little fun and see if we can give the soil some counter forces around it. What happens if we give the soil some counter forces? Haha. And we notice it compacted somewhat because I, just ran that down into it. But, so I guess I should fairness, but no, let's go for it. We're at 4, 8, 9, 10, 11, 12. Let me grab some more. $13, $14, $15, $16. See, we're coming about it differently. We're now we're countering. It's pushing out forces with a counterweight, if you will. So we're at 2, 4, 6, 8, 10, 12, 14, 16. I think it's close to trashing my camera. Let me 17, 18, ooh, hold on. $19, We're at 19. Look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 2, 4, 6, 8, 10, 12, 14, 16, 18, 19. Now, 19. Let's remove some counterforces that prove my counterforce theory. Right? 1. Don't hit me. Whoa. There we go. Let me put it back. All right, I'm terminating video. That will help you also identify where the force is. This is your sort of, you can visualize the load path now. You can see it in the diaphragm. Yeah, a load diagram. You know, you can